Question 2, this question is about acid-base titrations. Citric acid reacts with sodium hydroxide. There's the equation. The student makes a solution of citric acid by dissolving some solid citric acid in water. Describe a method to add an accurately known mass of solid to a beaker to make a solution. So this is testing your practical skills, and many students, including myself, are not very confident with the practical skills, and that's why I need to as well keep reviewing them, start reviewing them again. So measure the mass of the weighing bolt and solid. Add the solid to a beaker and then reweigh the weighing bolt and subtract to find the mass of solid added. It sounds complicated, but if you visualize it in your head, or you watch a video on it, it's not that complicated. We're measuring the mass of the weighing bolt and the solid, so we're measuring the mass of weighing bolt and solid. Then we're going to add the solid to a beaker, and then we're going to reweigh the weighing bolt. So we're trying to find out the mass of the weighing bolt. Once we find out the mass of the weighing bolt, we can do the mass of the weighing bolt and solid minus the mass of the weighing bolt, subtract, and therefore we'll find the mass of the solid added. 2.2, the student dissolves this much of acid in water and makes a solution up to 500 centimeters cubed. Calculate concentration mole per dm minus cube of citric acid in the solution. So first things first, moles is equal to concentration time by volume. So write the equation. So concentration is moles divided by volume. Okay, so now we know that. How do we find the moles? Well, the moles in this case can be the mass of the citric acid over the MR, the citric acid, which we don't have. So firstly, find out the moles, which is mass of MR, which is going to be 0.834 over the MR citric acid. Well, it's going to be 6 times by 12, 12 times by 6, plus 8, plus 16 times by 7. So 12 times by 6, plus 8, plus 8, plus 16 times by 7. Okay. 0.834 over 12 times by 6, plus 8, plus 16 times by 7. And I get 4.34375 times by 10 to the power minus 3. Okay. Let's also label that the MR is 192. In mark schemes, sometimes they want us to, in this case, it does want us to label the MR in this mark scheme of citric acid. It wants to know where you got, how you calculate the moles. It wants to show how you label the MR as this and then substitute that into MR, mass of MR. Therefore, concentration is moles divided by volume, which is this, but this needs to be in moles per dm minus cube. So therefore, we need to times by 10 to the power minus 3. So it's going to be this large number of moles divided by the volume, 500 times by 10 to the power minus 3. And we get 4.34375 times by 10 to the power minus 3 divided by 500 times by 10 to the power minus 3. And I get 8.6 69 times by 10 to the power minus 3. Okay, and then 2.3 and then 2.4, but 2.4 that's easy. So 2.3, a really long method, and then it says for each of the 3 steps, identify the mistake, explain why it is a mistake, and suggest how the mistake can be overcome. 6 markers, so it's going to be 3 stages. You know, you should have done so many 6 markers just by doing the past papers that you should know by now that if it's a 6 marker, it's 3 stages. So in chemistry, stage 1. So we know that we're using a measuring cylinder to transfer the centimeters cubed, 25 centimeters cubed of citric acid. So that's a mistake, using a measuring cylinder. What we want to do, why is this a problem? Why is it a mistake? Because large uncertainty, therefore not an accurate value. So use a volumetric pipette, not a dropping pipette. Volumetric pipette, not a dropping pipette. Stage 2, we rinse the burette with distilled water. That's a mistake. Rinsing the burette with distilled / deionized water. This is going to slightly dilute the alkali solution. So so how can a mistake be overcome? Rinse the burette not with distilled water, with alkali solution. Stage 3. What can you find? Add sodium hydroxide solution, drop by the endpoint till indicator changes color. Add 5 centimeters cubed of the indicator. Okay, so too much indicator is added, and this may react and affect the endpoint reading. So use a smaller volume, E.G, for example, 2 to 5 drops. Okay, that's 6 marks. There are 4 stages in this mark scheme, but it says choose the best 3 stages out of 4. So yeah, they mark you on only 3 of the best 4 stages. So 3 stages. It's 2.4. Complete table 1. So all we're doing is going to be 22.95. This one's going to be 46.05 minus 22.95. And here's a trick. 6.05 minus 22.95. We get 23.1. But we have to give it as all these values. 23.10. 26.30 minus 3.40. 22.9 in the calculator. 22.90. And then it says use dating table 1 to calculate mean titer. Mean titer is titers. You need to find the titers less than concordant titers, which are less than 0.1 centimeters cubed away from each other. So it's going to be this one and this one. So it's going to be 22.95 plus 22.90 divided by 2. 22.95 plus 22.90 divided by 2. 22.925 can be 22.93. I'm pretty sure in a mock maybe last year I gave it to like 22 for example. Here I wrote 23.1, probably a different question as well, but I got 0 marks because they in the mark scheme or something it wanted it to 2 decimal places for each of them. So 23.10. So it can be very strict, the mark scheme sometimes. So for these type of questions, make sure you give it to what these other values are like. So all these values are to 2 decimal places. Why are you going to give this value to 1 decimal place? You also should give it to 2 decimal places. And then 2.5, the total uncertainty in the use of the burette is 0.15 centimeters cubed. Calculate the percentage uncertainty in the use of the burette in run 1. So the percentage uncertainty is equal to the total uncertainty divided by the reading, total reading, times by 100. The use of the burette in run 1, well in run 1, the tie test 22.95, so it's going to be 0.15 over 22.95 times by 100. Do we times by anything, like 0.15 times by 2? No, because we're only finding percentage uncertainty in from one value, the run 1. If it was doing 2, like run 1 and 2, then we'd add them together, add them together, and then we also times the top numerator by 2. But we're not. We're only finding it the percentage uncertainty in run 1. So 0.15 over 22.95 times by 100. That'll give me 0.65%. 0.64. 0.65%. And that is the end of question 2.